The curve C has the equation y equals f of x. Given that f dash of x, so the gradient function, is equal to ax plus b, it passes through the point Q with x coordinate 1, y coordinate 5. The tangent to Q, the tangent at Q, is parallel to y equals 2x. So if it's parallel to y equals 2x, it's telling me that the gradient is 2 at that point. And the y-intercept is minus 4. We need to find y equals f of x. So let's use the fact that we know that the gradient is 2 at q, so when x is 1. So I know my gradient function, f dash, is ax plus b. And I know that that's going to equal 2 when x is 1. The gradient is 2 when x is 1. A times 1 is a. So I know that a and b add up to be 2. Next, I know that if I integrate my gradient function, it's going to tell me about the original function, f of x, which is going to allow me then to use some of these coordinates. Integrating the ax will give me a half ax squared. Integrating the b will give me bx. And then I will have a constant of integration that I'm going to call c. But I do know that the y-intercept is minus 4. So that's telling me that my y-intercept c is minus 4. I also know that when x is 1, y is 5. So if I substitute 5 for y and 1 for x, the 1 squared is just 1. The b times 1 is just b. I'm going to add 4 to both sides. And I'm going to multiply both sides by 2, just because I don't like that fraction. You don't have to. And now I'm going to use simultaneous equations to solve, to work out what a and b are. So if I subtract these equations from one another, the a's will be eliminated. So a take away a is 0, the 2b take away b is b, the 18 take away 2 is 16. So now I know that b is 16. I can substitute that back into here to work out what a is. So a plus b is 2. Subtract the 16 from both sides, so a is minus 14. Now I know what a and b are, I can plug those into my f of x function. A half a, so that's half of the minus 14, which is minus 7, plus the b, x, so plus 16x, minus the 4, and this is my f of x equation.